So in this question here, we are given the voltage waveform, and then we ask some questions on it. So clearly from this, we'll try and identify the cycle, the period, and then the peak value or the peak voltage, right? Okay. So from what we see here, we know that the peak value, the peak voltage is 10, right? So that's the peak voltage, peak or the maximum voltage, right? And then let's identify the cycle. One cycle starts from here, right? This, this. So this is one cycle, right? And then if that's one cycle, then we know that the period for one cycle, or the period, right, 6, right? So this here is the period, right? Okay. So the first question we ask on that this is that what is the DC value? The DC value in this sense is basically the average value, right? So what you're asking us to find is basically the average value, right? So we know the parameters we need now to find that, right? Okay, so let's see. So basically we are supposed to find the area under the curve, right? And then we divide it by the period, right, to give us the average value. So the area under the whole what do you call it, waveform function is this way. We have one area here, right? We have another area here. So basically this is the positive area and this is negative area, right? So this is the positive area and this is the negative area, right? So let's see how we go about it. So the total area under the curve, right? Let's write it 80. Is what do we have? It's a right angle triangle, right? Or it's a triangle, right? So that's half. That's for the positive side, right? See, half times base. The base is 4 minus 2, and then the height is what, 10, right? And for the negative side, we have half. The base is that's 6 minus 4, right? So we have 6 minus 4, right? And the height is what, still 10 again, right? So this is what we have. Right, so this is the area and height. So that gives us, let's see. When it comes to these ones, is and being able to identify the parameters for the thing itself, for the waveform itself, is very important. So you identify the cycle, the period. You should be able to see precisely where it starts and where it ends. So it makes the solving of the problem easier, right? So let's see. So the area, total area we have here, we have this, right? Okay, 4 minus 2, and then the height is 10, right? And then we have this inside. We have minus, so that's 1 on 2, right? Okay, so let's see. This is half. We have this. Okay, so that's 6 minus 4, and then we multiply it by 10. Right, to half times 6 minus 4 times 10. Right. So that gives us the area being 0. Total area 0, right? So let's take this down. So now that we know the total area is 0, just have to divide this by the period, right? So basically the average value that we are looking for is equal to the total area, right, all over the period, which we know to be 6, right? So basically that's 0 on 6, which ends up giving us 0, right? So 0 divided by 6, 0 divided by 6 gives us 0. So clearly the answer for this option here is the average value, or the DC value, is 0, right? Another one we have here is that we should be able to find equivalent DC value. The equivalent DC value here in this case is basically the, what's the name, the RMS value. Yes, the RMS value, right? So what this one, how we find this one is that we square the area under the function, under the waveform, and then divide it. So this is RMS, right? So let's see, RMS. So we square the area under the function, we divide it by the period, and we find the square root of that, right? So how we go about it is this way. When it comes to right angle triangle, right, the squared area, right, the formula for that one is no longer half times base times height, right? So if it to be just the area and the height to be half times base times height, right? So this is just area. This is just area for right angle triangle, right? Or a triangle. But when it comes to the squared area or the area squared, squared, let's make it, it's actually squared area. So when it comes to the squared area, the formula becomes, instead of half, it's 1/3, right? And then times base, right? And the height is rather squared this way, right? So we change this from this to this. So that's the squared area, right? Okay. So we find the squared area divided by the period, and we find the square root, right? Yeah. So let's see. So the squared area for the first part, we know it this way, right? So let's see. Total squared area, right? It's basically 1/3. So let's see. We are considering the positive side first. This one first, right? Right. So we have 1/3. The base is what? You know the base to be 4 minus 2, right? 4 minus 2, right? And the height is, what's the name? Is a 10, right? And we are seeing that we square the 10, right? So that's 10 squared. So that's the positive side, right? This is a squared area. But when it comes to the negative side, what happens is that because we square the area, this whole thing no longer won't be negative anymore, right? It will come up here, it becomes positive, right? So it will be something of this sort. If we square this area, the area becomes positive, right? It will no longer be negative, it will become positive. So we'll get something like this, but still the same formula, right? So we get a plus instead of a minus, right? You have a 1/3, and the base is it 6 minus 4, right? Let's see, 6 minus 4, and then the height is 10, still 10, right? So 10, but then the formula square, right? So this is what we have for the area. So that's 1 on 3 to bracket 4 minus 2, 4 minus 2, right? Times 10 squared, right? Minus, sorry, plus, right? And then we have what's here. So we have 1 on 3 times 4 minus 6 minus 4 is 2, right? 2, 2, and then times 10 squared, right? That gives us a total area of 400 on 3, right? Let's keep it 400 on 3, right? And then we know the period is 6. Period for one cycle is 6 seconds, right? Yeah. So that will mean that RMS value will be equal to square root, right? And then the total area all over the period, right? So this is square root. We have 400 on 3, and the period is 6, right? So let's see what we have. We have square root, and here we have 400 on 3, 6, right? So that gives us 4.71. Let's do 40p, 40 volts, right? And then this one as well to is volts. So all this here, just to clear the confusion, because you know that doesn't mean they are not voltages. These are voltages, right? And then yeah, this one too are voltages as well. Yeah. So clearly the answer for this one here is 4.71, which is B, right? So we have clearly the answer to be this here. All right.